if healthy people have body temperatures that are normally distributed with a mean mu of 98.2 and a standard deviation sigma of 0.62 degrees Fahrenheit, we can find the probability that a person has a temperature above 99.5 in the following way. We want the probability that a person, X, has a temperature above 99.5 degrees Fahrenheit. By hand, this would be two-step calculation. One, we need the z value, which is X minus the mean divided by the standard deviation, or 99.5 minus 98.2 divided by 0.62. Which is 99.5 minus 98.2 divided by 0.62, 2.09677. So that's approximately 2.10 if you round to 2 decimal places. Look at that second digit. 6 is big, so round the 9 up to 10. Now second, as converted this problem from an x value to a z value problem, what's the probability that z is more than 2.10? And to find that value, we look at the table. We either look at the negative version because we want to be right, or we find the area to the left and subtract it from 1. So here's our picture. 0 is the middle of the z value, 2.10 is way out here somewhere, and we want the probability that z is more or greater than 2.10. So that's this area of the curve. We can either read the area to the left of negative 2.10 by symmetry, or we can find the area to the left of 2.10 and subtract it from 1. 1 minus the table area of positive 2.10. So let's pull up the table and give those a look. Here's my table. 2.10 in the negative would be an easy table read. 2.10 right here, 0.0179. Or 1 minus the area to the left of positive 2.10 should give me the same value. So positive 2.10 has an area to the left of 0.9821, and the area all the way to the left. That would be this area. 0.9821. Let's make that subtraction and make sure that they work out. Minus 0.9821 is 0.0179. So sure enough, that's the probability that someone is more than 99.5 degrees. Now, what about B? A hospital wants to select a minimum temperature, like the minimum temperature for a fever. They need more tests after that. What should that temperature be if we only want 1.5% of healthy people to exceed it? Here's a curve. The average temperature is 98.2, and we want to find a temperature here that we don't know, find that x value, such that 1.5% or 0.015 of the area is to the right. It exceeds that value. What is the x value? By hand, we need to first determine the z. Find z. That means we look inside the body of the table for 0.015 inside the table, and then turn it into an opposite sign by symmetry, because if you find 0.015, you'll be finding an area to the left of this negative z. By symmetry, we can cook it up and find it on the other side, or we need to find the area to the left of this 0.015, 1 minus 0.015, that's all this area, and find that z value. So you have to pay for it either way. Either switch the sign or find the complement of the area. Let's find the complement of the area. Seems more direct. So 1 minus 0.015 is 0.985. So we're looking for 0.985 inside the body of the table. Somewhere in here, 0.985. Here's 982, 93, 984. No, look at that. Exactly 0.985. Then read the z value from there. 2.1, the row, and the column is 0.07. So that's 2.17. As the z value. Now we want to find, though, the minimum temperature, not the z value, not how many standard deviations above the mean we have to be, but what's the actual minimum temperature. So number 2, calculate x, where x is z times sigma plus the mean. So the z value we found, 2.17, standard deviation 0.62, and the mean temperature 98.2 should give us a minimum temperature for a fever, or to require further tests of 2.17 times 0.62 plus 98.2 is 99.54. I think 5454 maybe? What's it say? 5454 for a minimum temperature.